Welcome back to the channel. In this tutorial, I'm going to go through the process of creating a functional drawer slide from static models that are provided by the drawer slide manufacturer. We're going to be doing two types here. One would be a side-mounted ball bearing slide with soft close made by Knape Vogt or KV. The other is an undermount slide runner system manufactured by Salice. I've made a couple of other videos on this topic in the past, and you might be wondering, why is he doing this again? Well, there's two reasons for that. One is the Fusion team has made significant enhancements to the joint facility in the design space of Fusion 360, and that makes it much easier to establish joint relationships that have movement associated with them using an as-built joint rather than having to specify lots of offsets and other parameters to get the relationships squared away. The other reason is I'm doing a series of videos on building a bar cabinet, and we're going to be using these two slide mechanisms in that project as well. If you'd like to follow that project, I'll put a link up here on the screen and you can click on that and follow along if you'd like. So let's get started. Thanks for watching. So here we are at the K&V website, and this is the slide right here that we're going to bring into Fusion and model up as a functional slide for use in our other woodworking cabinetry projects. This is the 8450 FM. It's a 100-pound class or medium weight drawer slide with ball bearings and soft close, and it's full extension. So if you look here, there's 3D CAD models available. Let's click there. And the one I'm going to model today is a 12-inch. So we'll click on that. Let's download it. If you don't already have an account with KV, you'll need to create one and log in. So there we are. This step AP203, that'll work fine for importing into Fusion 360. So let's start a download here. It's generated the model for us, and we can download that to our computer. There it is. Let's open that. And it came in as a step file, or a zip file, which has automatically been expanded, and there's the step file that we can bring in to Fusion. So let's go to Fusion now and bring that in and start working on it. So here we are in Fusion. Let's go get that downloaded file from my computer. Here it is right there. And let's see what we've got here. Okay, we've got 6 bodies. So let's turn off these 3 bodies here, and I want to convert these other 3, that is our closed drawer slide, to components. Now, why am I doing that? You can't make joint relationships such as this slides against that with bodies. You can only do that with components. So let's get these 3 bodies converted to components first by clicking on the first one, holding Shift, click on the last one, right click, create components from bodies. So there we are. Let's give them some names. Let's turn off all but the first one here. So this is the component that attaches to the side of the cabinet. By convention, I always call this the rail. You could call it whatever you want. 2 slow clicks in these boxes and you can change the names. This one here is, that's this middle component that slides along and gives the slide the ability to fully open. I, by convention, call that the mid. And then this other one must be the one that attaches to the side of the drawer. That's it right there, and I call that the runner. 2 slow clicks, runner. All right, so we've got our 3 components there. Now, when all is said and done here, I want this drawer slide to come into some other cabinet model that we're working on as a single unit, not 3 individual pieces. So I want to create a new component here that will capture all 3 of these components inside it. and create one cohesive element that we can deal with as a single unit. So if we go up here at the top, right click, new component, and we can give this a name. This is the KV8450 12-inch slide. And now we can put these other three components into that simply by selecting them and dragging them into the component. So if we open that component now, we'll see there are our three pieces that make up this drawer slide, each one of them a separate component. At this point, if you were not interested in making this a functional slide, but were happy with it just as a static model, this is the point where we would create a joint relationship that's fixed in nature between these three components and save that off as an independent model. We can do that here. Let's just go through that process. So we have this particular component here enabled, which means we're working inside that component, not at the top level. We can add a joint here that will rigidly group all three components together. It's right here. It's called rigid group, and it wants to know what components we're going to rigidly group together. So we can pick these three, say OK, and now we have a rigid group joint inside this that makes all three of these components statically connected to each other, and they will not move relative to each other. Of course, that's not what I want to do here. I want to make this a fully functional slide, so I'm going to delete that joint that we just made. Right click, delete, and it's gone from our timeline, it's gone from our browser. Let's turn on the fully open slide and see when this runner component is fully extended, or the drawer is pulled out as far as it will go, what is that travel distance? This is supposed to be a full extension slide, but I know from experience that these shorter slides, like this 12-inch version, they don't fully extend to 12 inches. So let's see how far it actually does extend. And we can measure that. There's an inspect tool here with a measurement capability. And using that, we can compare the location of one surface to another, or one point to another. So the shortcut on the keyboard for the inspect tool is I. So we're going to inspect how this surface relates to this surface. It's 258.6 something millimeters. We can add inches as a secondary unit here and see what that is. So, as I suspected, it only pulls out 10.183 inches. That's good to know. You'll see why here in a minute. So one of the nice things about this measurement tool is if you just click on the distance that it gives you for that measurement, it puts that value on the clipboard. We're going to use that next when we establish the slider joint relationship between the runner and the rail. So let's close this. We can turn these off. The Fusion team has really enhanced one aspect of creating joint relationships that I've been complaining about for 7 years, and they finally got around to fixing it. And one of the reasons I wanted to do this new video on the slide was to demonstrate that capability. So it's using the as-built joint function to define joint relationships that actually move relative to each other. So rather than have to specify offsets and how this component relates to that physically in space, we can now just get the components positioned the way we want them as they are here and say, let's create an as-built joint, and we're going to create a slider, and we're going to define a sliding relationship between a couple of these components as they are currently sitting in 3D space. So let's do that. Let's turn off the mid and we'll work on creating a sliding relationship between the runner and the rail. So I'm going to reset that just so you see it again. So we're going to select the two components that are going to move relative to each other. So the runner is going to move in relationship to the rail. We've got those two selected. It needs a snap point, which is a reference point for the movement. So we can just pick that little point there on the front, and we've got a sliding relationship that looks correct. I just want to point out that if that wasn't correct, we could change the sliding relationship in various different ways here, but it's on the z-axis, and that looks good. We can also at this point specify how far this can travel. When it's at rest, what's its position? Well, this is the at-rest position, or when the slide is fully retracted. So we don't want it to go any further to the rear of the slide than it already is. So we'll just say when it's at rest, it's at 0, and when it's at maximum, we can use that value that we got from the inspect tool to define the full extent of that travel, and that was this 258.6 blah blah blah. So that's the full extent of the runner as it relates to the rail. Let's finish that joint. Notice that it's showed up over here called slider 5. We'll change that name in a minute. Now let's turn off the runner and turn on the mid, because the mid has a sliding relationship to the rail. Let's do that. We're going to assemble another as-built joint, and that's between the mid and the rail. Those two are selected. And the snap point, we'll just pick that same point on the front of the rail. There we are. That looks good. Now we don't need to establish joint motion limits here because the runner and the mid move in relationship to each other. And let me show you how we're going to do that. Let's close this. Let's rename this. This is the runner to rail. And this is the mid to rail. We can turn our runner back on. And now what we want to do is establish a relationship between how the mid rail moves in relation to the runner. So we know that, at least I know, that the runner to rail relationship is a 2-to-1 relationship. So as the runner moves forward, let's say 10 millimeters, the mid rail only moves forward 5 millimeters. So we can establish that joint relationship here under assemble, right here, called a motion link. Now with the motion link, you specify 2 joints and then put in the relationship between them. So we're going to create a relationship between the runner to rail and the mid to rail. And we've already got those distances put in here correctly. So what this is saying is that when the runner moves 10 millimeters, the mid moves 5. So that's a good relationship. That's exactly how it works. And we can say, okay. Now we've got our motion link over here and the 2 joints, and I think we pretty much got it. We're going to do housekeeping here in a minute. So what else do we need to do here? Well, probably be a good idea at this point to save this. So Command or Control S on the keyboard, and we're going to save this as KV 5450. We don't need this alphabet soup at the end there. 12-inch slide. And we're going to put it in a new folder here called Bar Cabinet Hardware, which I created offline. So we'll save it there. And I want to do a little bit more cleanup here. When we bring this model in to another, let's say a cabinet or a drawer assembly or something like that, we don't need these bodies here, which were the original open illustrations. So let's get rid of those. We really can't delete them because we use them in the measurement tool to define and figure out what the relationship is to from closed to open. And there are probably some other relationships that are established here when we brought in the model by the manufacturer. Let's just try deleting them and see what happens. So we'll select those 3, right click and say delete. I think we're going to get an error. Yep. Following features are referenced by downstream dependent features in the timeline. So we can't really delete that. Let's Instead, there's an alternative method here where we can get rid of it, but whatever information is in it that the rest of the model depends on sticks around in the background. So that's, if we select the features and right click on it, there's a thing down here called remove. So we got rid of those. There's one other thing I want to do here, and that is I want to turn the origin back on. There it is. And I like to work in a coordinate system where the z-axis, represented by blue, is up and down. The red axis is right to left, and the green axis, or the y-axis, is front to back in the models. So let's get this repositioned. So the first thing here in this is going to be a move command. It's under modify, right down here. The keyboard shortcut is M. It's also up here on the toolbar. So I'm going to say, let's move, and it wants to know, well, what are we going to move? We're going to move a component, a body, a face, a sketch object. So we're going to move a component, and this is the natural movement technique. You'll see here in a second when we specify the component that we're going to move. We're going to move this component, and now we've got the ability to move it up and down and rotate it and that sort of thing. So I want to get it rotated. Let's first turn it up this direction, and that would be front to back because it's on the y-axis. That's good, except it's backwards. So let's go up this way, turn it around 180 degrees around this way. So now we have the front of the slide at the origin of the model. And then there's this tool over here where you can specify a point to point. And let's do one other thing. Let's turn it this direction. There we go. So that looks good. In a cabinet model, that would be the left drawer slide. So let's click this, and now we can pick a point that we want to move to the center of the model here. So with that, I'm going to say I'm going to zoom in here, and I say I want that point right there at the origin. There we go. So now it's centered on the origin and it's in the right orientation. We say OK. We can turn off the origin symbols now, close these things up. We're going to do one more last save. And there we are. We now have a functioning 12-inch slide that we could bring into any other model and use as a component in creating our cabinet. Let's move along now to the Salice undermount slide runner system that I want to use in this next project, and we'll model up here. Let's close this and we'll go here. This is the Salice catalog, and this is the section on their runner system, and this is the runner that I'm planning to use, primarily because it will take a pretty heavy load of 170 pounds. It is, this runner series is suitable for door boxes with side thicknesses of 1/2 inch to 5/8 or 13 to 16 millimeters, which is what I'll be working with. They come in a number of lengths, shown here, 3 in fact, and this is the one that I want to model today. That's their 15-inch runner. So unlike some other drawer slide manufacturers, Salice does not put their CAD files online. You have to request them. I got a very quick response when I sent them an email on their website saying, can I get step files for your, and I called out the specific model number for this particular runner series that I wanted. They sent me a link from which I could download models. And this is what they sent, shown over here. There's a number of variations here. I assume these are all the different lengths. Yeah, there's the one I've highlighted there. That's 381 millimeters. That's the 15-inch. This other stuff, I've opened it before. It turned out to be clips and mounting brackets and various other accessories and that sort of thing. So let's go into Fusion. I'll show you what they linked me to here with this. Let's do a file open from my computer. And there's the list. So let's get that open. There's the 15-inch open. And this is what I got. Now, we've got a right and a left. If you open one of these, there's all kinds of components in here. And I ended up wanting to sort this out into the same kind of three basic components that we used on the KV slides of a rail, a runner, and a mid. And rather than take you through all of this, I reorganized this offline. We'll open that next and then set about making a functional model from there. So let's go open that now. So file open, and from my computer, and I stored them away in the same folder with the step files that I got from Salice. So here's the runner. Let's open that. And you can see if I open this one here, we've got a rail, a runner, and a mid. This one I didn't do that organization to, but you can see what all the parts are. I also converted the materials. There's some plastic parts on here, some ABS, that sort of thing. So I put those specifications in there. So let's start here. I think what I want to do now is get rid of this left-hand version. We will mirror our model here across and use that to create the left-hand version. So let's see if we can delete it. No. Actually, let's try and see what happens. That's fine. We didn't get any errors show up in the timeline. Let me just briefly show you what I did here in terms of reorganizing this. Let me get these open, and there we go. So I'm going to go back in the timeline to right here. I'm going to say roll history marker here. And there's the slide as it came in from Salice. And then I created, these three components here to move those things in. And I'll just click through here with the timeline and you can see what's going on. I'm just moving various components from the top level down into the individual pieces that create the three major components of the rail, the runner, and the mid. So now we can set about putting some motion things on here. Obviously, if you didn't want an articulating version of this, just wanted a static version, you could use the assemble command and create a rigid group like we did before with the KV slide. I'm not going to do that here. So let's just move forward creating our joint relationships. Okay, for this, let's turn off the mid and create the sliding relationship between the runner and the rail. We're going to use the as-built joint again, and we will say the components that we want to slide are this component in relation to this component, and it wants a snap point, which is a reference point for the slider mechanism. Let's just click there. Okay, we've got the sliding mechanism that we want. Let's, while we're here, establish the minimum and maximum. So minimum would be the current rest position of 0. The maximum would be the extent to which this runner pulls out of the rail, and I know that that is 381 millimeters because this is a 381 millimeter slide, and it does fully extend. So there we are. There's our slider. Let's animate the joint. And as you can see, the only component here that's moving is the rail. All of the other things that are inside, the runner. All of the other things that are inside the runner component are stationary. Why is that? Well, let's stop this with animation here with an escape. That's because inside the runner, there are all these components, and there's no relationship established in terms of a joint between all of these various features. So let's do that. Let's put a rigid group in here that attaches all these things together. So let's activate the component, the runner component. Let's do an assemble rigid group. It automatically selected all of those. Great. We've got multiple components in the rail, so let's do the same thing there. Let's activate that and do a rigid group, and it got all of those. You can see those joints show up here. There's the rigid group in the rail, and here's the rigid group in the runner. Now, if we articulate that slider with animate joint relationships, they should all move together, and they do. So that solved that problem. I'm going to escape to stop this, and as you could have seen there, I think it went the full 381 millimeters, and then when it came back, it didn't go behind the rail. It stopped where it's supposed to. Now the mid only has one component in it, so I don't think we're going to run into that same problem there. Let's close the runner and turn it off from view. So let's create a assemble as-built joint slider between the runner and the rail, and we'll pick another registration point called snap here, right there. Okay, that's going the right direction, so we're good there. Let's give these a name. So this slider is the runner to rail, and the other one is the mid to rail. There we go. Now we can establish a motion link between these two joints so that when the runner moves, let's say 100 millimeters, the mid only moves 50. So let's do that now under assemble a motion link, and we'll pick these two. And what have we got here? Let's turn on the runner. Okay, so when the runner moves 10 millimeters, the mid moves 5. Just for the purpose of demonstration here, let's reverse this. I'm going to make this 10, and you'll see that it, and make this 5. And we'll animate that joint relationship. So now you can see that the mid is going twice as fast as the runner, which is exactly opposite what we want. So let's stop that. We can come in here now, right click and edit feature on that and change these back to what they were originally. 10 here and 5 here. And, not 50, 5. There we go. Say okay. Now if we animate that joint relationship, we get the right behavior here. Okay. Escape to stop that. That looks good. Let's turn these off so we don't see them. And yeah, there they go away. All right, so we got our left hand one done. We need to create a right hand version to go with it. So this, let's save this down before we go any further. Command or Control S on the keyboard. Let's check our data panel here. There it is. Version 1. Okay, good. Now let's set about making the companion to go with this on the right hand side. So to make the companion to this on the right hand side, we're going to use the mirror command. And in order to mirror something across, we need a reflection plane to mirror against. So let's create that now. We'll do a construction offset plane, and we'll select this surface, drag it out here, and say OK. We'll use that for the mirror command now. The mirror command is down here. It's also in my toolbar. So we're going to mirror, and we're going to mirror components, not bodies. We're going to select that as our component to mirror, and we'll select this construction plane as our mirror plane. And there we have it. So now we can turn off that construction plane and take a look at what we got here. Now, let's open this up, and you'll quickly realize, if you look closely here, our joint relationships did not come across. And this is by design. Within Fusion, mirrored components do not mirror the joint relationships. So we need to recreate what we did up here. I will do that as a fast forward so you don't have to suffer through it again. And I'll come back to you in real time once those relationships are established. Okay, now that we've got our two companion slides here, the right and the left, we need the clips to go on the front. Those are the things that attach to the bottom of the drawer box and release from the runner if you want to take the drawer out of the cabinet. So let's go see what Salice gave us. File open from my computer. And I believe this last one here is the clip. Let's open that and see. Well, it is. It's upside down, but there's a right and left clip. Boy, there's the same kind of thing going on here. A whole bunch of different pieces and components in that. I think I'm going to go offline and clean this up. It's not really, it's not something that we need to apply sophisticated joints to or anything like that. So let me go offline, clean this up, and I'll come back. Okay, I put some fancy colors on here. Didn't really do much else, but we have a left clip and a right clip now. Let's save these. Command or Control S on the keyboard. We're going into that same hardware folder. Save. There's our left clip. Let's do the same thing with the right clip. Save. Let's open our data panel. Well, we got our left. Where's the right? Oh, there it is. Okay, so now we can bring those into this other model that we created with the runner and attach those to the runner. Let's do that next. Well, we got these saved out here to our data panel, so we can close these. And this one. So let's bring in the clip for the left-hand side here. First thing we want to do is get that component activated so that our import, which we'll do here, insert into component, will come into that runner component. And let's get it repositioned here a little bit. All right, it looks like it's upside down. Let's turn it over. .180 degrees. There we go. Good. Now we need to establish some relationships between where the clip attaches to the runner. We'll do that next. So the best way to do this is to set up some construction planes that represent the surfaces of the drawer box that would ultimately go on here. According to their Salice literature, the front of the drawer box is 4 millimeters proud of this front edge of the runner. So let's create an offset construction plane there. So we'll go there and we're going to come out the 4 millimeters. So that's where the front face of the drawer box would be, and this is set up to accept 13 to 16 millimeter thick drawer box sides, front and back. So let's create another construction plane that's offset from this one, and we're going to go back 16 millimeters. So minus 16. That is the back side of the front of the drawer box, and that plane represents where this element of the clip would attach to the underside of the drawer box. I hope that's clear. Let's turn off that first plane. Why don't we be tidy here and label this back of drawer box front panel. Now, we know that this is going to be coplanar with that, so we can use the align command to create that. Let's make this a little smaller so it's not so in our face. How about that? So let's do this. Let's align, and that features here on the toolbar. It's under Modify, Align. Let's align. We're going to select a component. We're going to align that face of the clip with this construction plane. I think we can turn that plane off now. We're going to, next we're going to align the top of the clip with the bottom of the bottom panel of the drawer box, which is the same surface as this. The drawer box bottom panel sits on top of that runner. So let's do that next. Align that surface with that surface. There we go. And we'll say OK here. And the next thing we know is that this edge of the clip rests against the inside edge of the drawer box side component. And the drawer box side rests against this part of the runner. So let's do another align command from this surface to this surface. And that should be where our clip attaches to the runner. Let's say OK. That looks pretty good to me. Now we can create a joint. Let's create assemble an as-built joint. This time we're going to use a rigid joint, and we're going to create a rigid joint between this part of the clip and that runner. And it should show up right here. There it is. So we can label this clip to runner. And you can see there's our joint symbol that tells us it's there. If we didn't know what that was or wanted to test it, we can right click on here and say animate joint, and the two things that are connected together will start to wiggle around. So as you can see there, escape to get out of that. Let's turn off that clip to runner joint so that little symbol goes away. Now we need to do the same thing to the right hand runner. So let's get that activated, and we'll bring in a right clip. There it is. Let's move this over. All right, so that's upside down as well. Let's turn it this way. So we did 180 degrees. That orientation looks good. So now we can do the same kind of alignment things. Let's get, well, we don't need the construction plane back because we can say align this face. All those little points are for specific point alignments. We don't want that. We just want the surface. So we want that surface aligned with this one because we know that's been established already. We want this surface aligned with that clip. and we want this surface aligned with the inside of the drawer box side, which is that surface right there. I think we're good there. Does that look right? Yeah, looks right to me. So let's assemble an as-built joint between this part of the clip and that runner, and it's rigid, and that should show up right here. There it is. We can call this clip to runner, and we can turn it off. Let's tidy this up. I think we're almost done here. Yeah. So we've got 2 runners and 2 clips. And now we can save this. Let's do that next. File. Save as. And this is, that's probably good. Salice, blah, blah, blah. And I like that at the end. So let's say Salice 15-inch undermount runners, runner pair with clips. And we'll leave the model number in there for reference. So when we get ready to order it, we know what we're trying to order. So we'll save that, and it should appear. There it is. And I think we're good here. I hope this was useful. If you have questions or comments, put them in the comments section below. I do read them all and I reply. And it helps me in the next video in terms of trying to adapt to your questions and where you get confused. I know this is complex. You can get confused easily here. So let me know. Hit the thumbs up or the thumbs down button if you would, please. Subscribe if you want to. And thanks for watching. See you on the next video.